Hi everyone, welcome to our video on finding the relative extrema where we have a natural log function involved. Alright, so it's the same thing. I'm scrolling, so it's this example still where we're finding the relative extrema, still this 5-step process that we'll break down. Okay, so and again, it doesn't matter what the function is, it's always the same deal. Alright, so with this, we see that it is a quotient. So, and also y, I'm going to just change this to be f of x. Let's just go ahead and rewrite it. So I don't really like y in these scenarios because I need to plug stuff in, like on what I did up here. And I don't really like y for that. So I'm going to change it to f of x. So that's an optional thing. Okay, so we have f of x equals x squared over ln of x. And then, well, this is the high portion. This is the low portion. So that means my derivative, f prime of x, is low d high minus high d low all over low. And then let's start plugging those in. So our f prime of x is equal to our low, which is the natural log of x, times the derivative of the high, which is 2x, minus the high, which is x squared, times the derivative of the low, which is 1 over x. And then all over our low one, the natural log of x, getting squared. Okay, so there's that. And then now I want to simplify my numerator. Notice x squared divided by x would simplify. And so we would have f prime of x is, so we have the natural log of x times 2x. On this, I'm actually going to just rearrange that first term. Let's put 2x first and then the natural log of x. So just as a preference thing, otherwise keep them in parentheses. And then minus x squared divided by x would be x. And then still over ln of x getting squared. All right, so we've got this scenario here, and then now I want to factor what I can in the numerator. So notice x is in common. So let's factor. So we have f prime of x is x. Let's get our big fraction bar, and then 2 ln of x minus 1 over ln of x squared. Okay, so this is our factored f prime. And what we do from here, since this is a rational function, so this was our first step, just getting the derivative. Our second step is now, with a rational function, remember to set the whole numerator equal to 0 and the denominator equal to 0. So we take both of them and set them each equal to 0. Okay, and then now I want to solve. Well, this first one, the first one is still a product. So the x times this. So that means this x I can set equal to 0. And then this 2 ln of x minus 1 I can set equal to 0. And so then I want to keep solving. This one is actually already solved. X is 0. This one I can add 1 over. So we have 2 ln of x equals 1. And then we could divide by 2 to get ln of x equals 1/2. Well, this is where, to get rid of an ln, we use e on both sides, which would leave us with the variable x all by itself. And then we're left with e to the 1/2. So that is our other critical number so far. Okay, and then in this last one, well, if I square root both sides, the square root of 0 plus minus is still 0, so because 0 doesn't have a sign. And then we have ln of x is 0 like this. And then if I use my e on both of them, okay, so just like before, if I use my e again, I would have my x all by itself. X is isolated. E to the 0 would become 1. There we go. Okay, so there it all is. Okay, so then we have our 3 critical numbers here in this problem, and now I want to set up my number line. So step 3. All right, so they're all positive, so I know 0 then would be the most left. Between e to the 1/2 and 1, you might need a calculator for this to view the actual decimals. The way I'm seeing it, I know e's about 3. The half power, okay, so this could be written as e to the 1/2. Remember, the half power is the square root. So the e to the 1/2, so you could rewrite it as the square root of e. Well, e's about 3. The square root of 3 is bigger than the square root of 1. So I know this is bigger than 1. So that's without using a calculator. But again, you could plug it in to really verify. Okay, so there's our number line setup. And then these are my x values. And then I have my f prime and then my f. All right, and then now it's still the same deal. Step 4, I want to plug in the values into my derivative, plug values in between my intervals into this derivative, and then I want to just check the sign. Okay, and you can start wherever you want. It doesn't matter. Let's go ahead. I'm going to start, let's do the far right. So let's do f prime. So we said e is about 3, so I want to choose something bigger than that. Let's choose 10. So f prime of 10. And then when we plug it into our derivative, I would have 10 times 2 natural log 10 minus 1 over the natural log of 10 getting squared. Well, all I care about is the signs. 10 is positive in the first parentheses. In this second parentheses, 2 times the natural log of 10 is a positive number. That would be bigger than 1. So when they subtract, it would still be positive. Natural log of 10 is also positive. When it's squared, it would stay positive. So all of these are positive. 3 positives divided is positive. Okay, and you could, again, the calculator can verify these. I'm trying to do it without any type of calculator, though, for now. So you could plug it in and really verify, though. All right, and then now I want to choose something in between 1 and e to the 1/2. All right, so without a calculator, something bigger than 1 would be like 1.01. And I think it would definitely be between these two. So again, without plugging in anything yet, I'm just choosing something very close to 1 that I would assume is between these two values. And it is, and when we plug it in, well, 1.01 goes into that x. And then we'd have 2 ln of 1.01 minus 1 all over natural log of 1.01 squared. Okay, so I've squeezed it all in there. Well, the 1.01 is positive. The 2 ln of 1.01 minus 1. All right, well, this is getting to be close. So the natural log of 1 is 0. Okay, so the natural log of 1, so natural log of 1 is 0. So the natural log of 1.01 would be close to 0. Something close to 0 times 2 would stay close to 0. Minus 1 would be negative. Okay, so that's breaking it down purely by without a calculator. Okay, so if you need to use a calculator, that's fine. I just want to try to break it down without one. Okay, and then the natural log of 1.01, again, close to 0, but it's going to be slightly bigger than 0. So positive value gets squared, and it would stay positive. Okay, so I have 2 positives and 1 negative, which would be negative. Okay, and as often, you might have seen the pattern, often it just alternates signs. So positive, negative is often how it goes. But still, it might be worth checking all of them. So 1 more, or 2 more. Anything bigger than 0, that's less than 1. Okay, so let's do f prime of something in between these. I'm going to do 0.1. Okay, so just a small decimal, bigger than 0. And then if I plug it into my f prime here, I would have 0.1 times 2 natural log of 0.1 minus 1 all over the natural log of 0.1 squared. Okay, so again, I'm breaking this down. 0.1 is positive. Now this, without a calculator, again, is pretty tricky, but what we're going to do this time, so if the natural log of 1 is close to 0, that means smaller than 1, natural log of something smaller than 1 should be negative. Okay, so we've got, so the natural log of 1 is close to 0, so it's in between, so anything bigger than the natural log of 1, actually, I don't think I need to write anything. Let's just state it like that. Okay, and I'm doing this without going to a calculator. You could just go straight to a calculator and plug it all in to really verify. All right, but what I'm saying is if it's smaller than 1 in this natural log, it would be negative. So 2 times a negative minus 1 would stay a negative. Oh, is it working? Oh, there it goes. Okay, I thought it was breaking on me. Okay, so we have, this would be a negative there. Okay, and then after that, the natural log of 0.1 getting squared eventually, well, the square here is automatically going to make things positive no matter what. Okay, so this is positive here because whenever you square anything, it's going to become a positive. Okay, so that one, now I just said it typically alternates, but notice on this scenario it did not. Okay, so we've got a positive, a negative, a positive, and then that would become a negative. Okay, so we've got a kind of a strange case here. Okay, and then anything left of 0, well, this gives us a problem. So if I choose anything left of 0, f prime of negative 10, well, we have a problem with the natural log. The natural log portion cannot be 0. Okay, so you cannot have, or cannot be less than 0. Okay, so we've got, let's put this down here. Rule, the natural log needs to be positive only. So the natural log of 0 and the natural log of a negative, those are undefined. Okay, so this doesn't exist. So nothing's happening over here. Okay, so that means the function, there's nothing going on. Okay, because our original function, ln of x, means we couldn't have anything less than 0, or we couldn't even have 0. Okay, so anyway, so what's happening here is that this function decreases, and then it continues to decrease at 1, and then afterwards it would increase. Okay, so there's our scenario. And this time around, it looks like there's only one. So if it decreases, then decreases. At only one point does it have a turning point. So that's going to be our relative minimum here. So we only have a relative minimum, which means our step 5 is to just plug that into our original function. So our relative minimum is to plug e to the 1/2 into our function. So the x squared becomes e to the 1/2 getting squared over natural log of e to the 1/2. Okay, and then what's going to happen here? Well, the 1/2 and the square, those multiply to give us just e. And then the ln of e to the 1/2, well, the rule with this is if you have ln of e, they cancel out, and you're left with just the power. So it is just 1/2. And then this would simplify into, so if we multiply both the top and bottom by 2 to get rid of the fraction, we would have just 2e. Okay, so that's it. So we now have it. So it's our relative minimum. So our relative minimum is 2e at x equals e to the 1/2. Okay, so pretty weird there scenario. Let's do one more time in the calculator. Let's plug that in. Okay, so I want to plug in x squared divided by the natural log of x. All right, so there's our graph. Okay, and notice like what I said. So this is based on the domain of the log. So let me put that in red. Let me just box it up. So this is, so ln of positive is defined. Ln of 0 or ln of a negative is undefined. Okay, so we have those rules there. All right, so, and at any point, so I mentioned it multiple times, you could have jumped to the calculator to help with this problem, especially with these parts where we were plugging it into the derivative. Okay, so, but notice it does match our number line, so it was decreasing, and it looks like there's an asymptote at 1. So let me just put in x equals 1. There it is. So there's the asymptote. And then afterwards, it's decreasing again. It's decreasing, decreasing, decreasing. And then at this point is where I have that local minimum, the 1.649 and the 5.437. Okay, and if you were to plug those in, so the 2 times e is 5.437. E to the 1/2, if we plug it into the calculator, is the 1.649. Okay, so you could rewrite those. Again, it depends on if they wanted them in decimal form or not. So if they said write exact values, so this is exact values. So that's where we have to do it by calculus. If they said decimals only, then you really could have just done this with the calculator. The relative minimum is that 5.437 at x equals 1.649. Okay, so those were to 3 decimals. So this is the approximation answer. Okay, but 2e is this 5.437. Those are the same. This one is just rounded. And then e to the 1/2 is this. Again, it's just rounded. All right, but that's that. Okay, so tough problem. The natural log can be tricky. It's got weird things occur with it sometimes, but still just stick to our main 5 steps. So, and these are long problems, so take your time with them. So stick to these 5 steps. They're a lengthy process. Be patient. Okay, and then always check with your calculator. Okay, so thanks for watching. That's all. If you have any questions, please let me know. Otherwise, I'll see you next time.